Hello, my name is Mark Riddoch, and today I'm going to talk to you a little about 3D printing. I'm going to briefly talk about some options for different types of common printers used. Then I'm going to introduce a project to illustrate some 3D printing principles. Following that, I'm actually going to do some work on designing something, preparing that for printing, and then I'll look at the finished article for the project in question. So what printer options are available? There are many processes available, and many ways 3D printers can work, and more being invented all the time. There are, however, two particularly common and affordable types that you'll find in the hobbyist market: the FDM or fused deposition model and the DLP, digital light processing, and these are the two that we're going to look at here. So what's an FDM printer and how does it work? Well, the video you can see on the right hand side is an FDM printer in action. The way it works is it builds up objects in layers. A filament, usually some plastic of some sort, is melted and then it is extruded through a nozzle. The print head moves in the horizontal plane, as does the print bed being, in this case, a metal plate onto which the print is being built up. As you can see in the video, the print head is moving from side to side and the print bed is moving backwards and forwards. Once a layer has been laid down with the nozzle, the head will move up and the next layer will be deposited on top. Hence the name, fused deposition modeling. Each layer is fused to the layer below to create a solid object. DLP printers work on a very similar principle. Objects still built up in layers, although this time we have a light sensitive resin that's in a bath in the bottom of the printer. There's a light source underneath and a screen. The screen is used to block out the light source. Where the light gets through to the resin gets cured. Once a layer has been exposed, the print bed will pull the model up out of the resin and the next layer is exposed, and it carries on like this until you have an object. So which sort of printer would be right for you? If you're considering buying it, what are the things you should be thinking about? So some factors to consider. I've illustrated here two common printers, one of each type. There's the post-processing involved. With an FDM printer, you have a plastic model almost straight away. You do have to do some cleaning up, and typically you'll need to prepare the surface for painting. However, with the resin printer, you have to do some curing, usually with UV light afterwards, and you have to wash the model to remove the excess resin. The other thing to consider is resolution. You can get much higher resolution with the resin printers than you can with the FDM printers. This manifests itself in the amount of surface detail that you get in your prints. You can get much finer detail with the resin printers. So that brings us on to the applications. Think about what it is you want to do with your printer. Are you looking at providing scenic items for your layout, for instance, in which case you probably would want a DLP, which would give you a lot more fine detail on the surface? Or are you looking at structural items, where you want the strength of the plastic that you get from an FDM printer over the resin that you would get from a DLP printer? Costs are the other thing. FDM printers vary in cost to buy, and the main running cost for them is the actual filament itself, whereas with the DLP printer you have to buy the resin, which tends to be more expensive for a given volume than the filament that you use in an FDM printer. You also need to think about the chemicals you need to wash the print with, which is usually some kind of alcohol, And also the screen on some of these DLP printers has to be replaced periodically, which is an additional running cost. So let's look at the project that we're going to use to illustrate the rest of this video. It's a 20-ton Simplex petrol shunter. The actual model itself was bought from Shapeways and is a 3D print using a commercial sintering process to create the plastic, not dissimilar to the DLP, but with a powder that's sintered together rather than a resin. Relatively easy to get hold of these things, and lots of designs that you can buy. So this is the one that I based the print on. It's 4mm scale, as you might be able to tell, and it's printed in their versatile plastic material, which is quite a hard material, but it does have this slightly powdery finish to it, so it will need some work before it can be painted. And the goal is to motorize it, so somehow to add some wheels and a drive mechanism, and that's what we'll go on to next. The first option I considered had absolutely nothing to do with 3D printing. It was inspired by an article on the Central London Area Group website about axle hung motors, and you can see part of their website here on the right hand side. I actually built an underframe for my Simplex out of brass using W-irons and started to look at putting the axle hung motors in. However, I very quickly decided that given the wheelbase of this Simplex, there was just not enough space to get both motors in, some kind of DCC decoder, and all the pulleys and drive bands, etc. that were needed. So I didn't pursue this any further. In order to save space, I thought a single motor option might be the best, still based on the idea behind that axle hung motor, but with one central transverse motor, and with belt drives going to each of the axles from that motor via an intermediary. This would need a symmetrical layout, and I started wondering if I could build this easily in brass, or maybe I could go for 3D print instead. And shown here is my design for such a thing, and this is where the next part of the video is going to go, is how this design came about and how it was created. So how do we create a design? You will get the greatest benefit from your 3D printer if you're willing to do your own designs. You can simply download things that have been designed by other people and print them, but of course you're then limited to what they've designed. If you've gone down the route of getting a 3D printer, you'll probably at some point decide you want to actually design your own items. The CAD tools that you can do this with do at first look quite daunting and difficult to use. Just like any tool though, as long as you put some effort in and are willing to learn how to use it, you can get good results without too much difficulty. The other thing that people struggle with is when they look at an object they want to design, it appears complex and they don't know where to start. So I'm going to offer a few ideas based on how I look at doing design. What I would stress, however, is when you do your first design, start with something simple. Don't try and create a very complex shape straight away. And as with all tools, you need to practice with it. So don't expect to be able to pick it up, do one thing, put it aside for 12 months and then be able to do it again. If you're anything like me, you will have forgotten how to use it by then. Really, as with everything, practice, practice, practice. So what sort of design tool would you use? Really, for 3D printing, you want some kind of 3D CAD tool, which makes sense. You can use tools like Google SketchUp, which aren't really a fully blown CAD tool, and you will get reasonable results, but you'll get much more benefit by using a 3D CAD tool. These aren't necessarily expensive, especially if you don't use them commercially. In fact, in the example I'm using here, which is Autodesk Fusion 360, it is free for hobby use, so I have not actually had to pay for this tool at all, but it is a very professional tool. So a few simple tips. How do you start designing something? Well, with Fusion, for instance, you start by drawing a face as a simple shape. So you break down your design into simple shapes and draw one face of it as a sketch. You then take that sketch and you can either extrude it, which is pulling it out to create a solid from it. This will give you a solid object. Or you can rotate it about an axis. In this case, I'll choose the bottom of this arch. And you can see how I can create a torus from it. So that gives you very simple 3D shapes. When you want to create more complex objects, you can do this by adding together several simple objects, or removing a simple object from a complex object to create a hole in an object. And we'll look into this in more detail when we do the demonstration of the CAD tool in a second. So I'm going to leave the video for part 1 here. The second part will, as I say, give you an example of doing the CAD itself and the printing process. We'll also look at the process of taking the output of your CAD package and sending it to the printer to be printed.